The calendar instantiate object from, a type, but object from Gregorian calendar, we still have access to the values from the abstract class. These are the attributes, right? And we can test the program running. It just returns the current date, system date, and time when you choose the default constructor. Right, like today, years, date, 2016, month. It's starting 0 is 1, so that's why 6 is July, and so on here. And you can specify, if you use the constructor with the parameters, you can specify your own date and time and calculate the actual day of that date. Alright, so now let's look at interfaces. So what's an interface? Why is an interface useful? How do you define an interface? How do you use an interface? So interface is a class-like construct that contains only constants and abstract methods. So there's no implementation in an interface. In many ways, an interface is similar to an abstract class, but the intent of an interface is to specify common behavior for objects. For example, you can specify that the objects are compatible, editable, clonable using appropriate interfaces. To distinguish an interface from a class, Java uses the following syntax to define an interface. So instead of public class, we say public interface and the interface name. Again, interface only have constants and abstract method. Example, interface is editable and abstract string how to eat. So that's the abstract method. So interface is a special case. It's treated like a special class in Java. Each interface is compiled into a separate bytecode file, just like a regular class. Like an abstract class, you cannot create an instance from an interface using the new operator. But in most cases, you can use an interface more or less the same way you use an abstract class. For example, you can use an interface as a data type for a variables as a result of casting and so on. For example, you can use an editable interface to specify whether an object is editable, like editable, right? So this is accomplished by letting the class for the object implement this interface. Like chicken implements the editable interface, and this editable has the abstract method name how to eat. And chicken extends from animals. So you can see now chicken is an animal. Chicken is edible. Tiger extends from animal. Tiger is an animal, but tiger is not edible because it's not implemented from an interface. Fruit is edible. So when you do implement in UML, you use dash. When you do extend, you use the solid line. Dotted lines, these are implements. Now apple extends from fruit, orange extends from fruit. They are all edible. Apple is fruit, apple is edible. Orange is fruit, orange is edible. So that's how we do the relationship here, using the interface. So let's look at an example code. So this is how you implement an interface. Just replace class with the word interface. And the method is an abstract method. No implementation. Now let's see how we're implementing it. So you may see we create a class animal as the abstract. So this has an abstract method. It may look similar to an interface, but it's different. Like interface only include the abstract methods, but abstract class you can have abstract method and non-abstract method, which is with implementation. Chicken extend animal. So chicken is an animal. Now this is how you use an interface. Implements. Use the keyword implements and eatable. Something that you have to notice that a class can only extend from one other superclass. But a class can implement more than one interface. Like I can say implement eatable, comma, another interface name, clonable, comma, comparable. You can implement as many interfaces as you wish, but you can only extend from one class. So you see something like that on the test. Now, how to eat, just override the methods, right? From the eatable. And sound is override the method from the abstract class animal. Tiger extend animal. Since tiger is not eatable, then we do not implement eatable. So we just override sound. And sound should be an abstract because sound of chicken is cock-a-doodle-doo. But sounds of tiger is different, so that's why implementation should be different. Right? So, same, fruit implements eatable because fruit is eatable, but we not extend from animals because fruit is not an animal. Then we are required to implement the methods. If not, we have to make it abstract. Right? Otherwise, you have to implement the eatable methods, right? How to eat. In this case, we make it as an abstract because we want to make it as the template for another class to extend. So apple extends a superclass fruit. So that's why apple is not an abstract. Then you are required to override the how to eat, as well as the orange, how to eat. And they all are abstract because the way to eat apple is different than the way to eat orange. We make an apple cider and we make an orange juice. That's a different way. So that's the benefit of using interfaces and abstract class. Now since we know that an interface always going to be public abstract methods, then we can just omitting the keyword public abstract. We can just say void p like that. As well as it's always a constant, then we can omit the keyword final public statics. They always public interface. All the attributes and methods in the interface are public, so we can omit the keyword public. Now the constants in the interface can be accessed using the interface name dot name of the constant. In this case, it's t1.k. Now let's look at a Java API. One of the interfaces comparable. So we already know that string has a method dot compare to, right? When you use string, compare to string, and see which one is greater. Just like dot equals, right? But compare to, if it's greater, returns plus, less than, returns minus, equals, returns 0. So that string actually, string class is implementing the comparable interface. So comparable interface has one method named compare to, with an abstract. So it requires to implement it. Now what is this A? This is just to make like generic programming. So you can make any object compares. String, integers, doubles. So we have to specify the type at the time of implementing. toString equals and hashCode. So each wrapper class overrides the toString equals and hashCode methods defined in the object class. We know that toString, hashCode, we know for sure toString is a method in the object class, and now we go to hashCode also. And wrapper class has to override those methods. Since all the dynamic wrapper classes and the characters class implements the compatible interface, the compare2 method is implemented in these classes. You may see that the integers is a wrapper class extends from number, also implements compatible. Extend from abstract class number also implement the interface compatible. And we have to give the type in integer. So this is generic programming. Then it's required to override compare2 methods when it's implemented, as well as big integers, as well as the string and date class. They all implement compatible. So then let's look at example. We can actually use integer3.compare2. Since they all implement compatible, we have an access to compare2 methods. So meaning that if you want to create a new object like student object and you want to compare to student, you can use the compare2 by making student implements comparable. Then students are required to implement compare2. And then inside the compare2, your method implementation is depending on requirements. You could implement by comparing by scores, or compare by student alphabetically name, things like that. And abc.compare2, this is a string version, toString compare2, right? And we create two dates. We can use compare2 between two dates. For example, how to use compare2. Sort. Generic sort method. So let's n be an integer object, s be a string object, and d be a string date object. All the following expressions are true. N instead of integers, n instead of object, and also instead of comparable because they extend, right? N extend from object, extend from number, which is number extend from object. Every classes in Java extend from object, and n is an instead of integers right there. And integer implements compatible, so that's why n is also instead of compatible. So n is integer, n is object, n is compatible. As well as s is string, s is object, s is compatible. As well as d is date, d is object, d is comparable because implements incompatible. Now we can use arrays.sort method, right? It requires the elements in an array are instead of compatible. So that's why we can sort. If the elements in the array is not comparable, you cannot sort. Like if you have an array of students and student never implements compatible, you cannot use array.sort and pass array of student in. But if I say student implements compatible and I implement compatible compare2, override that comparable abstract method, then I'm able to use array.sort and pass an array of student in. And then it's going to sort and just give the type of compatible as student. So we can look at example. So we have a string list of cities: Savannah, Boston, Atlanta, Tampa. We can just do sort. Since city strings and string is already implements comparable, you can sort that easily. As well as the big integers, we can just do sort.